All right, let's talk about AI agents. Everybody's talking about them, but it is so easy to get lost in all the hype, right? So, are they just a fancier version of the software we already have, or is this something totally new? Today, we're going to cut through all that noise to answer one simple question. What's really different? Let's dive in. Okay, right off the bat, this is the single biggest shift in how we need to think. For, decades, we've built software that just executes our instructions. It's like a hammer. It does exactly what you tell it to do, and that's it, nothing more. AI agents, though, are different. They pursue your objectives. You don't give them a step-by-step list. You just give them a goal, an outcome you want to see. And this really gets to the core of what we're talking about today. We are seeing this massive move from software as just a passive tool that we have to operate to software as an active collaborator, an actor that actually works alongside us. Now, think about what this quote is really saying. It's all about the shift in responsibility. When a system just runs tasks, the human, you're the project manager. But when an agent owns goals, it basically takes on that project management role itself. I mean, that's a huge difference in autonomy. So, to really get what makes these agents so unique, let's just compare them side by side with some tech we already know. We're going to look at 4 different examples to see exactly where the old way stops and the new way really begins. Let's start with something a lot of us are familiar with, multithreading. At its core, it's all about making software run faster. But how does that stack up against what an agent does? And you can see it right here. This is the classic difference between just pure efficiency and actual strategy. Multithreading is all about efficiency. It just runs the instructions you already gave it at the same time. An agent, on the other hand, is a strategist. It looks at the goal and then decides which tasks are even necessary in the first place and what's the best order to do them in. So, when you boil it all down, multithreading is all about the how, how to run things faster. But these agentic systems, they're about the what and the why. What actually needs to be done, and why is this the best next step to get me closer to my goal? Okay, let's move on to our next comparison. Natural language processing, or NLP. This is the tech that lets us talk to our computers and it feels very AI, So what's the real difference here? I love this distinction because it's so clear. Traditional NLP is reactive. You ask it a question, it gives you an answer. It's a simple transaction. But for an AI agent, language isn't just for understanding what you said, it's like its internal operating system for thought. It literally uses language to reason with itself, to create a plan, and to decide what it's going to do next. And that right there is the key takeaway. We're moving from a system that just processes language to one that uses language as a tool for its own autonomous action. It's kind of like the difference between a translator and a diplomat. All right, comparison number 3 is all about memory. Complex apps, they use databases to remember things. This feels a lot like memory. So, how is what an agent does any different? The real keywords here are passive versus active. A database is basically a filing cabinet. It holds records, sure, but it doesn't learn from them. An agent's memory is active, and it's contextual. It doesn't just store facts, it stores experiences. It remembers what worked before, what didn't, and it uses that knowledge to make better decisions next time. And that's the thing, right? Agents are selective. They don't just hoard data. They actually curate a memory so they can improve over time. It's the difference between a library full of books and a scholar who has actually read and understood all of them. And for our last comparison, let's look at systems that are built to help us make better choices. Decision support models. These things analyze data and they give us recommendations. Sounds a lot like an agent, doesn't it? Well, here's where the agent takes this massive leap forward. A decision support system stops at the recommendation. It presents the options, but a human still has to be the one to pull the trigger. Agents, they close the loop. They don't just advise, they analyze, they decide, and then they execute the plan themselves. And that's really the final piece of this puzzle. An agent isn't just going to show you flight options. It can be empowered to monitor the prices, wait for that perfect moment, and then go and book the ticket for you. It moves from recommendation all the way to resolution. Okay, so we've seen how agents are different from all these individual technologies we know. But what's the magic trick? What's the core architectural innovation that ties this all together and makes it possible? This is the real breakthrough. So first, let's look at the old way. Traditional software pretty much works like a production line. Input goes in one end, it passes through some fixed logic, some rules, and then a final output comes out the other side. It's a straight line. And if any one of those steps breaks, the whole process just fails. Now look at the new way. This is the agentic loop. It's not a line, it's a constant cycle. The agent starts with a goal, it reasons about the best action, it takes that action, and then, and this is the most important part, it observes the result. It sees what happened, and then it feeds that observation right back into the next cycle of reasoning. Yeah, this loop, it's literally the whole game. The ability to act, observe the outcome, and then self-correct based on that feedback, that is the fundamental engine of autonomy. It's what lets an agent persist, handle failure, and actually get smarter over time without a developer having to go in and rewrite the code. Okay, so we get the mechanics. It's a goal-oriented, self-correcting loop. But what does this all actually mean for the real world? Why is this such a big deal? What's the so what? Well, it matters because this isn't just an upgrade to what we had before. It's an entirely new category of software. You'll hear experts call it a new system-level abstraction. In simpler terms, we've basically invented a whole new building block for creating technology. It's software that can manage itself. It's not just a better tool, it's more like a new kind of digital worker. And if you take one thing away from this whole explainer, let it be this. We're not just talking about a smarter algorithm. We're talking about a completely new architecture for how software can operate in the world, autonomously, persistently, and with a sense of purpose. So I want to leave you with this question. We spend our entire lives telling our software what to do. Now we're on the edge of being able to simply tell it what we want to achieve. So if you could give your software a goal instead of an instruction, what grand challenge, what amazing thing would you ask it to take on? Just think about that. Thanks for watching.